let's talk about the universe. The universe, the eternal fabric of time and space, the last frontier, the final challenge. For years, man has dreamed of venturing up into this unknown realm. But how much do we really know about it? Sure, we know it has black holes, planets, stars, etc. But what if there's more? What if the universe started as an explosion? What if a black hole releases its contents? What if time travel is actually possible? Physicists and cosmologists work on unraveling these mysteries, and many of their names have gone down in history. For example, Isaac Newton, Albert Einstein, Galileo, and the most famous scientist alive today, Stephen Hawking. Stephen Hawking was born on January 8, 1942, to Frank and Isobel Hawking in Oxford, England. Stephen was the first of 4 children, and when he was 8 years old, the family moved to St. Albans. He went to the St. Albans school, where he was teased and bullied because he was skinny and spoke strangely. He got average grades in class, though he was an extremely smart boy. In 1959, Stephen went to Oxford with a scholarship. He took a mathematics, physics, and chemistry course here. He also joined the school rowing team as the coxswain, the person who steers the boat. Yet, even at Oxford, he didn't try his best. Soon, he headed off to Cambridge. He came home one winter break, and his parents immediately knew that something was wrong, due to his awkward motions and strange form of speaking. At a New Year's Eve party, he met Jane Wilde. They were soon engaged. Sadly, in 1963, he was diagnosed with amyotrophic lateral sclerosis, which is ALS. ALS withers all the muscles in the body, so you're basically paralyzed. Doctors give him only 2 or 3 years to live, yet he exceeded this time limit using his sheer willpower. But facing death inspired him to actually try and give studying his all. So he worked hard, got his PhD, and in 1965 graduated from Cambridge. On July 15, 1965, he married Jane Wilde. He also got a job at a section of Cambridge called Keys. At Keys, him and his associates started wondering, how did the universe start? Eventually, they went back to a theory called the Big Bang. It was laughed at years ago, but they found an equation that proved it. To show it to you, I need a volunteer. Okay, let's see. Gabby. All right, Gabby. Let me see. It should be. Anyways, just hold this balloon above your head. This is going to be our star. Now, oh God. Just keep looking straight. Oh my God! Now, 15 million years ago, our great star here exploded. This one won't explode. Okay, now that you just saw what the Big Bang did, here's what happened. So 15 billion years ago, this star exploded. This created lots of heat, radiation, and particles, as you can see on the floor. Now, all this finally cooled down 700,000 years later. And then soon, gravity started clumping it all up into the universe we know today. Stephen also came up with another revolutionary idea. It was called Hawking radiation. Now, to understand this, you have to understand a black hole. A black hole is a star that collapses on itself. So it gets really small, and its gravitational focus is really strong. So it can even suck up light. Now, when a black hole is feeding, it spins. Take a look. Alright, done. One second. There. This is our black hole. It'd be feeding right now. Now, anyways, Hawking radiation works because of matter and antimatter. Both of these are inside a black hole. The second they touch each other, they give off these huge explosions. It's like Sean Connery meeting a Terminator. Now, in these explosions, radiation is released. This radiation escapes the black hole and is called Hawking radiation. Now, for his discoveries, he won the Albert Einstein Award of Louis Strauss Memorial Fund in 1978. He also won a bunch of other awards. He was also appointed as the Lucasian Professor of Mathematics in Cambridge. This is a post Isaac Newton once held. While he did this, he was also writing a book with Bantam Books. This book would be called A Brief History of Time. He worked at CERN at this time as well. And one day, his nurse found him suffocating. Doctors did an operation that saved his life, but destroyed his voice. He was forced to talk out of the machine for the rest of his life. Now, he came out of the hospital and in 1988 finished the book, A Brief History of Time. He also wrote two other books called The Universe in a Nutshell and Black Holes and Baby Universes. Sadly, in the summer of 1990, he divorced Jane. But in 1995, he married Elaine Mason. Now, Stephen also believes in two other ideas, aliens and time travel. Now, first, let's get into aliens. When you think about the billions and billions of stars, galaxies, planets, etc. that are out there, the possibility of life on at least one of them is extremely high. I mean, I'm not saying that little green Martians are going to come with laser guns and blow up the Earth anytime soon, but there's an extremely high chance that there's life in a planet outside of our universe. I mean, galaxy. Now, time travel. To understand time travel, you have to get this. Time is a function of light's frequency. Did anybody understand that?
Yeah.
Okay. Well, the first thing you gotta get is this. Light travels in waves. Up and down like a bunch of squiggly lines. Just close this. Now, the amount of waves in 1 second is the frequency. Let's just say there's this much waves in a second. Alright? Let's call this the frequency. Now, time is light's frequency. So this is the amount of waves there be in time. Remember that. That is extremely important. Now imagine this. There's planet A. And then we have planet B. Captain Kirk wants to get from planet A to planet B. Seems pretty simple, right? Except that there's 1 trillion miles in between them. So he decides to speed things up a bit and go faster than the speed of light. Remember, time is light's frequency, so it is basically light speed. If he went faster from planet A, which will be at 1 o'clock, to planet B, he would go faster than light. So by the time he goes to planet B, light would be following behind him, and he would have beaten time. The only problem with this is that going faster than the speed of light is physically impossible. So Captain Kirk, get out of your dream. But he could do one more thing. It's called a wormhole. A wormhole is a hole in space and time. Now, what might feel like 5 miles in this hole could be 1 billion in real distances. So if he opens up a wormhole from here to here, and he goes through it fast enough, he can easily beat the speed of light, and he can beat time. Alright? Now here's some fun facts on Stephen Hawking. Now, he was on The Simpsons and Star Trek. He got his favorite movie is Some Like It Hot. His favorite band was the Beatles, and he got hit by a taxi once. Now, here are 2 pictures of some stranger versions of him. This is Lego Stephen Hawking. This is Stephen Hawking on the Wii, as the Wii character. Alright. Now, I've been talking a lot about him, but just for just a minute, just take a look at him. Look at this guy. He marches onward with this impish grin of his, getting closer to answering some of the biggest questions of our universe. Yet how does this 65-year-old man in a wheelchair do it? It's his impenetrable optimism and strength of mind that keeps him going. Stephen should be an inspiration to all of us, as a scientist and a human being. Adam?
It's a rip between space and time, which is like 5 miles, could be millions of miles.
Well, kind of, but it's not exactly a rip. Jay?
It's just a sudden hole in the universe where if you go right through it faster than the speed of light and time.
Well, yeah, I guess it's close enough. All right. How is Hawking radiation formed? All right. Nico?
When 2 black holes touch each other.
No. Jay?
When the Big Bang Theory happened, it emitted radiation called the hot bang.
Not really. Trey?
When matter and antimatter collide?
Yes. All right. Any questions?
What was the disease here again?
He had ALS, or amyotrophic lateral sclerosis. It basically paralyzes you. All right, Fabian?
How does the machine that he has to talk through, how does it work?
Well, there's a bunch of phrases on there, and he just uses a mouse to click on them.
Can he type his own?
Yeah, he can type his own in also. And, Sean?
How did you make a little black hole spin? Was it like a motor?
Yeah, there's a motor behind it. Nico's question. Was it your question?
Yeah.
Okay. So basically, because light's frequency equals time, just remember that's the amount of waves in a second.
Yeah.
Time is basically light speed. Just think of it that way. Because if there's this much frequency and 2 seconds, there will be this much. Okay? So if time is light speed and you go faster than time, you would kind of be going faster. If you go faster than light, you would go faster than time. And if it's 1 o'clock here, by the time light gets there, you would be there. And so you go faster than time.
Oh, okay.
Right? Jill?
Can I have the proof of wormholes?
No, we don't have proof of wormholes existing. It's just theoretical, because it should exist. Okay, Jay?
How many different types of black holes are there, and what do they do?
Well, there isn't different types of black holes. There's only one type of black hole. All right, Sean?
If the black hole sucks you or something up, where does it go and what is it like?
First of all, nothing can go. We can't see what happens in a black hole because you see, the way satellites work, it shoots out radio waves. Yes, Cameron?
If a planet implodes, what happens to it?
When a planet implodes, well, what I think would happen, I'm not sure on this, is that it would just turn into like a bunch of fire and just shoot out. Because a planet isn't big enough to be to squish itself enough to create a black hole.
Thank you.
Right? And if we tried sending a satellite through there, the black hole would just suck up the waves. So, and plus we can take a few guesses. Like, 1, it could lead to an alternate universe. That's one guess. 2, it can completely strip you of your particles and send you out as radiation. 3, inside, scientists believe there's something called a singularity. That's where everything gets extremely, really, really dense. If you touch the thing, you would get stuck there forever. Lori?
What's his last name again?
Hawking. And time would stop. So whatever, the point is, if you go through a black hole, the chances are you're not going to end up too well.